Okay. All right, it has started to record, and that's good.
Sir, do you put every recent recording in the recording folder?
Yes, it's automatically saved.
Okay, thank you.
Okay. So now this basically whole paper is of 30 marks, and out of 30 marks, you guys need to remember that 15 is for the first question, which is a written question, and the next 15 is for the other question. All right. So I just want to basically explain this to you this way, that the first question is a planning question. It usually has a diagram, and they want you to basically plan or design an experiment. Now you need to set your mind as if you are the examiner and you're writing O levels ATP paper. Do you guys get it? You remember paper six?
Yes.
Now
No,
it is
because
sort of,
me and Abu Bakr took the exemption.
yeah. Oh, okay. Okay, so all right, that's between you and Abu Bakr. So I don't know. All right. So what I'm saying is that this kind of paper, I just want to tell you, needs to be, you need to have that mindset that okay, I am the examiner. I'm gonna basically set this paper according to this. All right, like that. So let's have a look. Now for this one, um, if you basically look at the question, it has given that there is like moving air, right? And then in this moving air, there's blades which turn. This is a wind turbine, and there's a cable, and there's a pump, and the pump has a pipe in it, and there's a liquid. Obviously, as the turbine would move, the pump would run due to induction. All right, so you guys have done this already in IGCSE, and because of that induction, the current that is supplied to the pump, it will cause the liquid to move to a height. Do you guys get it? So from the from uh, the whole thing, I can understand this. Get it?
Yes.
Now, now, usually what they would say is that the turbine is placed in a moving air. As the turbine blades turn, electricity is generated, and the pump pushes the liquid. Like I said, the frequency of rotation is F, and the liquid moves through height. The mass per unit time of the liquid moving is Q. All right. Now it says that it is suggested that Q is related to F. Now these two quantities are need to be like, these are our main quantities, I would say, which means we are going to basically design an experiment according to these two. They have also given us a relationship, which is good enough. The important parts in this is they would say plan a laboratory experiment, like I said, between Q and F, right? And then they say where the G is the acceleration free fall, CD are some constants, and you also need to explain how the results could be used to determine the values of C and D. So basically, we got to plan an experiment. Ultimately, we need to analyze how we can find these values. So this is basically the question, and it will always be with different type of questions. It would be the same scheme at least. Now, it is very important to draw the diagram. How they have said it, you don't need to follow this procedure at all right, what they've written, you don't have to write this, but you have to follow the procedure I'm telling you now. All right, so let's go forward. First of all comes the when we are gonna define the problem, right? So it's called defining the problem. So usually what I do is I put it in headings, and I also write it in bullet points, because that would help me gain the maximum marks, as the examiner will be, it will be easier for him to understand and give you marks for each particular, um, you know, each particular section of this question. All right, so it's a full written question. Now, first of all, I'm gonna basically write what is the independent quantity, and then I'm going to talk about the dependent quantity, And then I'm going to talk about the control variable. Control variable means that we need to make sure that stays constant, right? So write variable. All right. So what do we mean by independent and dependent? Independent basically means that the quantity that we can change. And dependent means that changes due to independent. All right, so this is what it means. So the first one we can obviously change. So in this one, let's have a look. So we need to plan an experiment between Q and F. Q, it says, is the mass per unit time of the liquid leaving the top. Now that is not in our control. Our control is how the what is the frequency of the rotation. Obviously if we increase the moving this strength of air or the speed of air, whatever we're doing, we can control the frequency of the plates moving. Do you guys get it?
Yes.
So this means I'm going to say in this one the independent is going to be what I can control is F, and Q would be the independent dependent variable. Now what do we need?
Sir,
Yes.
in this case, since we can't directly control frequency, we can control the strength of the moving air and then by as a result the frequency. So shouldn't we write the moving air strength?
No, the moving air strength, you're right, we can control that. But then it affects frequency. So basically, frequency is in direct control. We need to,
Alright,
between these two variables that he has asked to build the experiment upon. Do you get it? You can't go
alright.
beyond this part. Understood? All right. Now, let's look at what we get. All right. So, where was I? Where was I? Okay, you forgot. Okay, now yeah. So now we need to know how to control a variable that's very important. Now in this one, if you look at the whole equation, we have managed frequency, we have managed Q. This stays constant with G. These two are constant. So H is the only variable that can change. What is H? That is the height of the pipe. So obviously, the amount of water that spills out of it basically should not depend on changing height. So we need to make this experiment fair. So we will keep this constant. Do you guys get it? So I'm going to say control variable will be that h should stay constant, right? Now, once you've done this, you have basically set the right tone for the experiment. And we are going to start with writing the method of this experiment, right? What is method? Method means how we're going to basically take or collect data, right? How we're going to measure things, how we're going to calculate things. We're going to write it here. So for method, first of all, you need to draw a diagram, right? So usually diagram has to be very, very neat. It should be labeled and it should be very detailed, because I'll tell you why it should be detailed at the end. All right. So obviously we need to basically do something with the turbine. So we're going to set up it on a bench. All right. So I'm going to make a bench. Usually you put these slanted short lines to show that this is a wall or a floor, like that. And on that floor, I would like to have, if I were you, I would make it like this. I'm going to make a turbine. Right? So let's put it at a height. So I would recommend that you basically take your rulers, your other drawing apparatus. It's very important to make it as neat as you can, right? So this is our turbine. And obviously I want to have a blower or a fan that I can control, right? So what I can do is I can put, okay, so if you do not know that how I can basically draw a blower, you can simply make a box, all right? So, and label that box. You can also alternatively put a, you say alternatively, you can also put if basically a fan. It's okay, by the way. So let me just, I wanted to erase this. The only mistake I did right now that it should be of height that it's directly perpendicular to where we're going to send the air, right? So in this one, I'm going to say this would be my turbine, wind turbine. This is going to be my air blower. Is it clear, everyone?
Yes.
So in case if you basically draw a fan, if somebody wants to draw a fan, just draw it like this. It's okay. You can basically draw a fan like this, and then alternatively you can write fan. So that would be, but these should be like directly in front of each other. Should be very important. Now you just draw a cable, take a cable, and then draw the rest of the things like they have shown. Sometimes they don't show anything, so you guys need to be aware that how this can be, drawn neatly. So you can do this. You can check out the diagram. There's a pump. That cable goes through the pump, and then there's a pipe. So we're gonna basically draw the same thing in here. So we're gonna draw this like this, like that, and then we're gonna make it like this. Okay, so like that, and that would be the level of water. So I'm assuming I'm using no colors in this because I'm just thinking that in the paper you just have a pencil, right? You can do it with a pencil, by the way. You don't have to do it with a pen because if you make a mistake, then you can't, erase it. It would be very, very bad. And then you can take a cable, connect it here, just label it cable. This will be your pump. This will be water. This will be your container. So label everything that you can. All right, it's very, very important. Anyway, then here you can connect it with the box again. Put a box here, and when you write put a box, just label it. This is a uh, variable power supply. Now, the reason I'm putting a variable power supply is because I want to control the speed of the fan. Do you guys get it?
Yes, sir.
I'm
Yes.
thinking about everything that I should be putting it on. Then, obviously, yeah. So then I need to think that, okay, I need to find Q. Q was the mass per unit time of the liquid leaving the top of the pipe. So I need to think about that. How can I basically take that, right? Let me think. I don't want the pipe to be collected on the. I don't want it to go back into this. So what I'm going to do is I'm going to put a pan balance here. All right. And then I'm going to put on top of that pan balance, I'm going to put a beaker. Okay, you guys, or some kind of, thing like this. And I'm going to basically put a hose or a pipe that should look like this, and it should come down and put the liquid inside it. Do you guys get it? I'm going to write hose.
Yes.
Yes.
You can write pipe. This can be labeled as mass uh, balance, right? So you can also write pan balance. Okay, pan balance. This would be a beaker. All right. Now, because the amount of mass that is collected over time, I need to use the stopwatch as well, but I don't need to show it because it has no basically use other than collection by humans. So I don't need to show. I need to show other things. Is it clear, everyone? Now, I don't think
Yes,
I
sir.
can actually make it more, say, detailed than this. So once you've done this, this whole exercise is going to give you a minimum of 1 mark. So I'm just going to tell you that this part, Let me change the color. This part is of 1 mark, writing independent, independent. This mark is 1 mark as well. So total marks for defining a problem are 2. Now for methods of data collection, the total mark of these are 4. So for diagram, you're going to get 1 mark at max. I'm saying at minimum, sorry, you're going to get 1 mark if you have the right diagram, but I'll tell you why I need a detailed diagram later. So now I'm going to write first about the things I need. So I'm going to say that first of all, basically connect a hose on top of the pump and measure the time of a certain amount of mass collected in the beaker. You guys get it? Like that. Now, how? Using a stopwatch. So I need to tell that here so that the examiner know that I know I'm taking it from the stopwatch, okay? Now I also need to basically write how we can basically measure the frequency, because obviously we're doing that. So we're going to say the turning of plates can be uh, found out using the time it takes to rotate in one oscillation, and then frequency can be found by F equals to 1 upon T. Do you guys get it?
Yes, sir.
Now, in my mind, the thing is that I am basically thinking if the fan, like if the turbine is moving too fast, right, then I cannot see exactly how many rotations it has made in a certain amount of time. So this is basically a big inaccuracy that I'm writing. Do you guys get it? But I'm actually intentionally doing this. I'll tell you why later. Is it clear, everyone?
Yes,
Yes.
sir.
Okay. Now, the third point would be use a pan balance to measure the mass collected per collected and then use mass over time to find Q. Do you guys get it? Like that. So now what I've done is I've basically looked at the equation itself. I know that I need basically Q. I told them how to find Q. I've told them how to find, I haven't told them how to find H, right? So I will write that too. And then I have also told them how to find F. So I'm basically on the completion of this. So use the fourth point, find height H using a meter rule. Get it? So I basically made sure that I have written every piece of information that I need, and I've told them how will I gather that information. So this will give you 4 marks. Do you get it? In fact, in this one, I've written 4 points, but don't worry about that. I've actually given one extra point, but that's going to help me later on. So you don't have to worry if you basically in your mind there are more points than they require. Is it clear, everyone? Should I
Yes.
go forward now? Okay.
One second,
Yes.
zoom out on this page so I can take a screenshot.
Yes, please.
Thank you, sir.
Okay. Now comes the third part of this question, which is called analysis. So you're gonna give the heading analysis and see I'm writing everything in points. Now, what is analysis? So first of all, you're gonna rewrite that equation that they've given to you. The equation says QGH C plus DFQ. QGH CFDFQ. I think this C plus, oh, that's correct, right? So this is the equation. Now, generally speaking, I'd like to tell you that usually in physics, what we do is on x-axis, we put the independent quantity. All right. This is basically a convention that we follow. And on y-axis, we put the dependent quantity. Is it clear?
Yes, sir.
So on the side of this, you got to basically rearrange this. We know that in our defining the problem, we have stated that independent is f, so f should be on the x, and q should be on the y-axis. What I'm going to do is I'm going to make q the subject of this equation. So I'm going to put q here. This will be c over gh plus df cube over gh. Any questions there?
No.
Then rearrange it once more. Bring d over gh times f cube, separate the x part, and c over gh. Now you can basically compare this. Like in paper 3, you used to do y equals to mx plus c. So you know that if you want a straight line with an intercept, on y-axis you should have q, on x-axis you should have frequency q. The gradient of this equation will be d upon h, and the y-intercept will be c upon gh. Is it clear?
Yes, sir.
Now you're ready to write this. You're going to say plot a graph of um, a graph of q on y-axis and f cube on x-axis. Then you're going to say then just write this very important point where you're going to say relationship is valid when the line is straight and passes through a y-intercept. Is it clear, everyone? So this will give
Yes,
you
sir.
one, right? So then, when you've written this, now there was a very important question in analysis. They said you need to tell us how to find C and D. All right. So this was their question. So we're gonna go back. We're gonna see. Okay. Now we're gonna say gradient is equal to d over gh, which means that d will be equal to gh times the gradient of the graph, right? Is it clear?
Yes.
Then the y-intercept is equal to c over gh. So it means c is going to be gh times y-intercept. Writing this part is essential. Do not leave it at this point because then you will not get any marks. Is it clear?
Yes, sir.
Right. So once you've done that, analysis basically has 3 marks, right? So I'm going to tell you what 3 marks it has. So the 3 marks include writing this, and writing this. The other things that we have done, this is for your own self. This is not graded at all. Understood? So you can also do it on the side if you want to. It's okay like that. Once you've done the analysis and you've answered the questions, then comes what are the safety precautions you're gonna take?
How much time do you have for question one, by the way?
Sorry?
How much time is allocated for question one?
The whole paper is of 1 hour 15 minutes. Ideally, you should be completed by this question 30 minutes.
30 minutes.
Yeah, 30 minutes because the
There's
other
no part A, no part B, just one complete question.
one essay type question, yes.
All right.
Hmm. Now, kids, once you've done that, you got to learn what safety precautions I should take. Now, safety precautions, the mark for safety precaution is just one, by the way, in the exam. But you can write as many as you want because there's no negative marking, and they're not going to pick the first one. They're going to pick the one that is correct. Do you get it?
Yes.
Okay.
For example, if I were you, I would have written that obviously there has to be some sort of precaution related to how air and dust is going to be there, right? So I would say you should take precaution to prevent dust from blowing air going into eyes, and that precaution is use goggles. Is it clear? Like that. Alternatively, you can also say that because it's a moving, they're moving parts, all right, and there's a lot of air pressure that's on turbine. So securely clamp the turbine and fan so they do not fall. Is it clear?
Yes.
And then probably they might ask you about, this is a water experiment, so sometimes water would get spilled and then people could, slip. That is an issue, right? So to prevent slipping from water uh, on the floor, use a bucket or absorbent sand under the table. Is it clear? So that you could not slip. Is it clear, everyone?
Can't we
Some,
also write something regarding use insulation such as rubber gloves because we're handling with wires and water?
yes, you can also write that as well. All right. So it's basically sort of a big, uh, you know, but you can't write that, okay, wear helmet, right? You should not write that. You should make sure that it's some sort of arrangement that is close to the real thing, right? Is it clear?
Yes, sir.
Now, the most important point in this one, which has actually 5 marks, is the additional details. Now, this is why I told you these 5 marks, you need a minimum 5 additional details. If you've seen the experiment that I've written, it's a very basic experiment. What I've said is, okay, you can find frequency by taking time of one oscillation. And I've told them how you can basically take the amount of mass and blah, blah, blah. And I have not given very precise details. So what I always do is I have a scheme. My scheme is that I write a very basic experiment, and then when it comes to the additional detail, I improve that experiment. So the examiner knows that okay, I know that there's certain things that can be used to improve this experiment to make it more accurate. Do you get it? So this is a plan of mine, right? Yeah. So one of the reasons that comes in my mind, and usually these reasons are the most repeated ones. So first of all, always write, repeat the measurements of Q for same values of F and take average of Q. Do you guys get it?
Yes.
Then I told you that basically I wrote that there is a variable power supply. So I'm going to say use variable power supply to change the speed of fan to change frequency of turbines. Write the full words, do not skip anything. Is it clear? Write like this.
Yes.
Okay. Make sure the airflow is steady before you start the stopwatch, because we don't want like changes in the airflow, and then it would give you an error when collecting the water, right? So water would change like that, right? Now the issue is that I cannot see when the fan is moving too fast. I cannot see that. So what I'm going to do is I'm going to basically use a video, and I'm improving the thing that I've written there. Use a video camera with slow motion playback with timer. Do you guys get it?
Yes.
Then take time of number of oscillations and divide it by total time taken, which is now I'm right, the time period will be n by t. Do you get it? Like that. Now what I've done is I've written a very simple experiment. Now I'm improving on it. So the examiner, oh, he's so cool, like that. Okay. Now 0.5. Okay. So usually what I do is in the exam I skip this part. I just basically write it somewhere, probably here or here, and then I use these lines. So don't go overboard like this. Just to explain you, I wrote it here. Okay. Now I'm writing. Keep on writing whatever you get. Right. Now I'm gonna go, so I've done Q, I've done F, and now I need to improve mass, right? So automatically I'm just thinking about it. Oh, by the way, how would we know even in the camera which when the oscillation is completed? So you can basically,
We just use the video playback, record the video with the stopwatch in view.
no, but then you do not know when the oscillation is completed, because you know there are multiple blades,
So
right?
we paint one of the fan blades red or
Yeah,
any other color.
a blade, one blade,
सर हर एक पॉइंट का एक ही मार्क है
huh?
एक पर पॉइंट वन मार्क है इधर
Yes, each point is one mark. So paint one blade of the turbine with a dark color. So when it completes, you know. Do you guys understand what I'm saying?
Yes.
Now six, coming to mass, I would say take mass of empty beaker first, then basically mass of liquid collected will be equal to mass of liquid plus beaker minus mass of beaker. Is it clear?
Yes, sir.
Just a second. Huh? Assalamu
All right.
alaikum. Walaikum salam. Yes, Ali. Walaikum salam. जी अली. अच्छा ठीक है ठीक है भिजवा दो ठीक है अली मैं जो है ना आपको थोड़ी देर तक करता हूँ मैं अभी जरा बिजी हूँ मैं करता हूँ ओके ऑलराइट नाउ you guys understand this
Yes.
अब्दुल वहीद को वैसे सीरियसली नहीं थी उसने अभी ना क्लास स्टार्ट
what timetable mark is that all right is it clear now I've done this now I've tried to write I don't think I have any other points but now I'll basically show you why I have done this in detail all right so this would be what I wanted to I hope you guys understand how to write this. This will give you like all the marks here. But
Yes, sir. Can you just zoom out so I can take a snapshot?
yes, why not? You can take it.
Okay, sir. Then thank you.
Okay, now I just want to basically last 2 minutes I'm going to take. Let me see what paper is this. Feb March. Wait. So I'm going to compare this with the mark scheme, what they say, and see we're going to grade ourselves what we should have done, what we should not have done. So where is it? 2023. Oh, they do not have that paper. So bad. Okay. GC guide. No, 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 no. Wait. It was March QP MS52. Okay. So in this one, okay. So let's look at the first one. All right. So they have said you should have f as an independent variable and q as a dependent variable. We have done that, 1 mark, right? Then it says that you should have keep h constant. We have done that, which is 1 mark again. Do you guys get it?
Yes.
Yes.
In the label diagram, they've said fan is positioned in line with turbine, so the blades of both fan and turbine overlap. We have actually done that pretty nicely, which is good, right? This is just a thing you could only see. Get it? So that's pretty good. And then it says base of fan on the same bench as turbine. Okay, we didn't know that, but we have done the same. Like we put it exactly where it is. Fan labeled and other one another from bench, wind turbine, cable pump, pipe, liquid. Now they have not asked us to draw anything else. Like we drew variable power supply, we have done a container and a pan balance speaker. They've not asked us to do that, right? But now I'm going to tell you why it is so important to do this. For example, they said that label practice showing workable method to collect the liquid from the top of the pipe, hose, pipe, tube connected, top of the pipe with other over a beaker, measuring cylinder, top of pipe, at least one label related to collection of liquid, right? We have done that. So we received 2 marks. Then it says use stopwatch timer to measure collect time. We have done that. We've written that. And then it says use stop and balance to measure the mass of the liquid. We've also done that. Is it clear?
Yes.
Now, suppose if you guys have forgotten about writing the how you would collect mass, but you have actually shown it here, like we have, then you would automatically gain this mark from there. Do you get it? So that is why I emphasize on writing or drawing a detailed diagram. Is it clear? Okay. Then it says you need to plot a graph of Q against FQ. We have done that. C equals to DH, GH minus times Y intercept. We have done that. GH time gradient is D. Everybody is clear about that? Now they have given us additional details. They say precaution linked to spilling of liquid, which is good. Linked to dust particles, use goggles. Precaution linked with tube falling, turbine clamping. That is fine. We have done that. Now, interestingly, in the additional detail, they have said use rule to measure H. We have not written it in these 6. Do you understand? You've not done that. But since I wrote it here, that find the height using a meter rule here, basically I'm automatically entitled to this mark. So you can basically write it anywhere, they will give you this mark. Do you get it?
Yes.
So
Yes,
this
sir.
is why this is so important, right? And then it says determine. You have to do mass of beaker plus liquid. We have done that. Okay, so we've done that. We've given that. So 1 mark. Determine method to determine f every time for many rotations. So they say you need to write this formula. That it should be time period should be n over t, which we have done. That's pretty good, right? So yeah, We've done that. And then it says mark one blade to assist in counting. Mark, we have painted it. We have not marked it, but we have painted it, which is the same thing. We're good people, right? Is it clear?
Yes, sir.
Then method to vary the speed fan. Now, even if let's suppose a fan was doing that, and he forgot that okay, how would I change the speed? But he has shown that I have put a variable supply against the fan, so he will get this mark even if he has not written in the additional detail. So your additional detail method and other marks can still be, you can score them from the diagram itself. Get it?
Yes.
Yes.
Okay. So then basically, huh? Uh-huh. Then it says, wait for the air to steady that we have written. We have not written Q, which is mass of the liquid, but actually we have written this here. We wrote that use a pan balance to measure the mass, and you can collect Q by doing mass over time. So if we written it here, we can get this D8 marks here. Do you get it? So
Yes,
that's
sir.
why we had an extra point in method that we thought, okay, we have done something extra, but that's good because you can get that mark anywhere. And this is a very common one, repeat measurement of, the independent, sorry, dependent value for the independent one, take average that we have written in the first part. So that's how we're going to score this. Now, again, I'm telling you, if you think that there are 10 or 20 additional details, just write them down because they're only going to check which are correct. All right.
Sir.
They're not going to penalize you for wrong.
Regarding these additional details, suppose you give a detail which according to you seems correct, but they didn't mention in the mark scheme. So will we get the mark for that or no?
Logically, mark schemes are made by the examiner to help teachers or the other examiners to check on a certain scale, right?
All right.
But if examiner feels that that reason is correct, should be included, it will be included in the mark scheme at the end as well. Mark scheme is developed after they check the papers. Do you get it?
Okay.
So it means these things, obviously, the students have written it and they have, made it sure that you include these. So the other thing is that even if something is wrong that you've written, but you've written seven additional details out of which two are wrong, you will still end up getting 5 out of 5 in this because
All right.
basically they do not do negative marking or first come first serve. They don't do that. They just check all the points and whatever are correct, they just mark them. Is it clear?
Yes.
All right. I hope I have made this clear, the first question at least. Now, for the second question tomorrow, I just want you guys to revise your uncertainties a bit because uncertainty is a big part in that. And just revise that. We're going to go towards the next question tomorrow.
Okay,
All right.
sir. Allah Hafiz.
Have a nice day. Bye.
You.
Okay, good luck.